on this track, it will use power from the track, and as soon as it's off it, your IC engine starts and then it continues to run. So we'll automate it also eventually, and that is the whole concept. This is the first stage. The second stage is to add fruits, vegetables, crops and medicinal plants harvested with a service vehicle. So imagine this vehicle and you have 4 arms, robotic arms on this, and that vehicle services the entire road. Alright, it will repair it, it will build it, it will plant the seeds, it will harvest it, it will water, and it will, it will repair the roads, it will build, construct houses, all of this through the service vehicle. This is the eventual goal of Road to Satyug. So that maintenance, construction, development, and also the ecology is all serviced in this universal service bus or a universal service vehicle. So USB, what we're just trying to keep it as USB. So that's the idea. I'm going to quickly demonstrate this. Currently drawing power from the bottom and the top. The thing is that we had rollers here. Okay, if you can see, these are rollers. So you can use many methods to make this. Now we have chosen this because it's the most easiest method. The teams, when they build it, they can build the attachment in the front or at the bottom or at the back or at the top. It is depending on the team. If they are able to do it from bottom and get more speed, they will use that. The engineer will decide where it has to go. And the even more innovative idea is called a wheel motor or a hub motor. The motor is present in the wheels itself. So we don't even have to attach a new segment to the vehicle. We can simply remove the vehicle tires and replace them with new ones, which we have hub motors. And once the hub motor goes onto the track, it will pull power from there and you can simply go. So you don't have to change any of the existing fleet. The existing vehicles don't change. Only attachment will change or the tires may change if we do it that way. If the teams decide to do it that way. Alright, with that I'm going to give you a couple of laps of this. So as you can see, it draws power from the top as well as it, it's giving its turning. So we can have it automated. We don't actually have to drive our vehicles. You can simply put it on the app, and then once your car is on the road, it simply keeps going on and on. So that is the idea of this Road to Satyug engineering competition. Teams will build something like this, and then they will have the laps going. Eventually, we have teams who will start slamming and road so that they will be doing different methods of drawing power from there. So that's the idea. And I'll tell you a little bit about this road itself. So this is made out of this bottom part made of plywood, of a 900 plywood, and then we have this other scrap material. This particular thing on top, this at the bottom is just a steel sheet which we CNC cut and we round it into the shape in the track. Alright? So this is just a rod, a simple rod which we use, a simple rod, and we put some water on the rod. This is the track. It is made from recycled, almost recycled materials, except for the plywood which was made in the track. Other than that, everything else is recycled material. Even this model is made through children's toys. This is basically a hobby made bottom. This is a hobby made bottom. So, and it's a hobby made. Child can make this, but we are making engineers do this. So imagine what we can make. So this is the idea of the and this is all about. So we are going to make this highest load and most efficient. So we have base, track, vehicle, finished. This is what we are trying to achieve in the Road to Satyug engineering competition. Thank you so much. Thank you so much.